Hello, welcome to my YouTube channel. In my previous video, I had discussed the high level overall architecture of Kubernetes, and this time we'll do a deep dive. I will discuss how the various components of Kubernetes interact with each other. So, let's get started. We know that the master node of Kubernetes consists of the API server, scheduler, control manager, and the etcd. And the worker node consists of the kube proxy, kubelet, container runtime, and pod. Okay, so any interaction begins with the API server, right? That's what I mentioned. Now, to set up pods and make sure containers are running, you do not necessarily directly talk to the pods. You can, but you might want to do it through a YAML file or deployment file. See, a deployment is an abstraction for a pod. So you mention the things that are to be deployed in a YAML file, and then what you do is go on the command line interface, you type, suppose the name of the deployment file is deployment.yaml. What you do is you go to the command line interface and then type in kubectl apply -f deployment.yaml. So what happens then is this goes to the API server. Now the API server validates this request from kubectl, right? Uh, it validates in the sense that it authenticates it first. It authenticates the request coming from kubectl, making sure that the source is a valid source. Okay, and then after authenticating, it performs a authorization, and then it writes the thing to writes it to the configuration etcd data. So we have mentioned the etcd, right? So um, etcd serves as a central store for all Kubernetes configuration data. So this is written basically, right? The API server writes the validated deployment configuration to etcd. So from then, what happens is the control manager process. See, we are trying to describe a process through which a pod gets created. So that's what I'm trying to describe. So what you do is you pass the things through YAML file that goes to API server. It gets authenticated and authorized there, and then it's written to this etcd, and then configuration controller manager comes into picture, right? It makes deployment controller for pod creation, and then the replicated controller comes into play for the pods. Okay, now once this is done, the scheduler begins its action. What it does is it assigns that created pod to specific nodes based on resource availability, constraints, and other factors. So it's very organized, right? So the scheduler looks at all these things and assigns pods to specific nodes in the workflow, right? So once that is done, um, the API server now, see, it needs to create the pod, but it doesn't do it directly, right? It does it through kubectl. So the API server, after the scheduler does its job, like making sure that the pod is assigned to a new node, what happens is the kubelet is notified through the API that okay, the kubelet is told to go and create a new pod, right? It gets the information about the new pod. And what the kubelet does is it performs a reconciliation loop to ensure that the desired state of the pod matches the actual state. Now, next, um, it's like the kubelet then orders the container runtime to create or update the containers within the pod. So that is what happens. Um, API doesn't create these things directly. It doesn't create the containers directly. The API server tells the Um, Scheduler, the scheduler goes and again tells the API, and then the API tells the kubelet to do certain actions. Kubelet interacts with the container runtime. The container runtime creates the containers. So that is how the whole process works. Now remember this, that you tend to use see, Kubernetes is a container orchestration tool, right? So when is this useful? So this is useful when you have a lot of services made in the form of microservices. See, these microservices are, if there are too many containers running the microservices, it is difficult to handle them manually, right? So Kubernetes helps in that orchestration of the containers. Now, there is a history behind this. Um, See, Google had a lot of containers running and they wanted a container orchestration tool. So they created a software called Borg. So that Borg system was a container orchestration created by Google to manage its containers. But later on, they created a different version and made it open source, and that became known as Kubernetes. Kubernetes is also also known as K8, right? So uh, Kubernetes, I just looked up. Kubernetes actually in Greek means helmsman. So helmsman is somebody who is probably the controller of a ship, right? So you might see the cog or the wheel in Kubernetes symbol, the icon, right? So that is what it means. So I hope you guys got some information on Kubernetes and the workflow. So keep watching my channel. Take care.